It's Christmas 1956, and John and Mary Holter have just been given tragic news. Their newborn son is hydrocephalic, a condition in which the secretions of the fluids within the skull increase out of control, putting pressure on his tiny brain.
We didn't think that it would happen to our baby, but it did. And this took several months for it to materialize, and then it was through a lot of process of tapping, draining the head each day through the ventricular system, removing the excess fluid pressure. And I was terribly upset about that, and I wanted to do something.
Medical technology at the time offered little hope to the child. John, an engineer by trade, was determined to save his son's life.
The hydrodynamics of it I understood pretty well after they explained the basis. And it took me 3 weeks to find the proper materials.
John worked feverishly day and night until he developed the first implantable valve for the treatment of hydrocephalus, saving the lives of his son and countless others.
And that little valve, like this one, worked fine for the rest of his life.
Over the years, this method of using a pressure-sensitive valve to shunt or drain off excess cerebral spinal fluid has become the standard practice in helping people with hydrocephalus lead more normal lives. However, though valves have been modified and new ones introduced, they all work on the same basic principles as those invented by John all those years ago and are not without their problems.
All shunts are pressure-regulated devices which require either low, medium, or high pressures. And they operate at a specific rate or a specific pressure determined during manufacture. This presents problems for the patient because patients vary in their needs between patients and also on a daily basis. And so what we've done is tried to create a shunt which is essentially universal.
Phoenix Biomedical, the company founded and inspired by John Holter's dedication to treating people with hydrocephalus, has developed a radically new valve that works to regulate the flow of cerebral spinal fluid much as the body does, and virtually eliminates the problem of overdrainage and the so-called siphon effect.
The siphon effect is when a patient goes from a laying down position to the standing up position, and there's a sudden flow of fluid out of the brain, through the shunt, and into the abdominal cavity. This can cause adverse effects.
These three valves are functioning as they would if the patient were lying down. When the platform is lowered to simulate the patient standing, flow from the standard valve increases dramatically, which can cause serious complications due to overdrainage. The anti-siphon valve prevents flow, but this can cause problems due to underdrainage. The flow-regulating mechanism of the diamond valve maintains flow at physiological rates, permitting the body to adjust naturally to changes in position. Dr. Evan Zeiger of Alabama's Caraway Medical Center, the Norwood Clinic, was one of the first neurosurgeons in the United States to use the newly designed valve.
We're quite encouraged and even excited about new valves that function in a more physiologic fashion. The old valves responded to pressure inside the head so that the fluid would drain at a certain pressure. But that's not the way the brain works. So we chose a flow-regulated valve and performed the shunt. And here you can see, compare this picture to this picture, you can see that the ventricles are definitely smaller. This is immediately post-operative, and already the patient is beginning to improve, wake up, and function normally.
Sometimes medical advances come from the most unlikely sources. It can take the vision of great men of science and years of research.
Because my own baby is terribly sick. He wouldn't live very long if we didn't do something.
Or it can take something as simple as the love and devotion of one father for his child to bring hope and life to countless families and their children.